Hello my dear KCET warriors, welcome to Deeksha Karnataka YouTube channel, and in the KCET PYQs of high weightage chapters, today I am going to discuss two very important chapters. First of all, current electricity, which is considered to be the god chapter of physics. Every year 6 questions approximately comes from this chapter, 5 to 6 questions comes from this chapter, and alternating current is also another important chapter. From this chapter also you are expecting at least 3 to 4 questions. Okay, so without any delay, let us start with today's session. And if you have not yet subscribed to our channel, don't forget to subscribe to our channel, share this with your friends so that you don't miss out on any KCET or PU2 related updates and all the teachings that is happening in our channel. Also, I request you to join our WhatsApp channel if you want to get the PDF of this lecture as well. Now, first we will be discussing 15 questions of current electricity and 15 questions of alternating current one by one. So current electricity is first question. In the following circuit, the terminal voltage across the cell is. So here there is a circuit diagram and they asked you what is the terminal voltage across this battery, right? Now if there was no external resistance involved, then we could have said that the terminal voltage is directly 2 volt. But you cannot say that terminal voltage is 2 volt because there is an external resistance connected. So how to do that? So for that, first of all, you have to calculate what is the total resistance of the circuit. Total resistance of the circuit is given by obviously R plus small r. This is the total resistance, RT. Okay, R is this external resistance is R and this one is small r. So if you add them, you will get the total resistance. So let's add them. Very simple. 3.9 plus 0.1, that is 4 ohm. So 4 ohm is the total resistance. Now what will be the current in the circuit? Current in the circuit is given by the EMF of the cell divided by the total resistance. EMF in this case is 2 volt, resistance is 4, so this will be 0.5 ampere. So 0.5 ampere is the current in the circuit. Now how to calculate the terminal voltage? Terminal voltage is given by epsilon minus I into R. Okay, every formula we have studied right in our textbook. So epsilon was given by 2 volt minus I is given by 0.5 and R is given by 0.1. So it will be 2 minus 0.05 or 1.95 volt is the terminal voltage. So if you take a voltmeter and put it over here, this resistance is included inside the battery, right? So when you take a voltmeter and put it over here, you will measure 1.95 volt and not 2 volt. Okay, so correct answer is 1.95 volt. Next question. Two cells of EMF E1 and E2 and internal resistances R1 and R2. It is mentioned that E2 is greater than E1 and R2 is also greater than R1 respectively are connected in parallel as shown in the figure. The equivalent EMF of the combination is E equivalent. Then what is the relationship between E equivalent, E1 and E2? That is what you have to find. Now very interesting is that the values are not given, but that will not stop us, okay, to solve such questions. Whenever some condition is given, and they asked you what is the equivalent resistance, if the same question was asked with some values, that would have been much easier. But values are not given, but it is mentioned that E2 is greater than E1, R2 is greater than R1. So what we will be doing, we will assume that E1 is 1 volt, R1 is 1 ohm, and so we will assume that, okay, because if the values are given, we can apply some formulas and we can calculate the equivalent EMF and equivalent resistances. Okay, so E2 is say 2 volt and R2 is 2 ohm. Okay, now if you see that this condition is validated, and we only need to find the equivalent EMF of this combination. Okay, so how to calculate the equivalent EMF of cells in parallel? Here you can see the cell are connected in parallel combination. So this is point A, that is point B, that means they are connected in parallel combination. So equivalent EMF in parallel combination is given by E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2. Okay, this is the easiest way to remember the equivalent EMF. So E1 by R1 plus E2 by R2 equals to 1 by R1 plus 1 by R2. Right? Now we will put the values. E1 is 1 divided by 1, E2 is 2 divided by 2, and here we will get 1 by 1 plus 1 by 2. So we get, on top we got 2, okay, and in the division we got 3 by 2, so we get 4 by 3. So 4 by 3 is 1.33. So what is the meaning of that? So this is an in the question it is arbitrary values are given, but arbitrary values we cannot manage. We cannot say what is greater, what is closer. Okay, so after calculating this we found that 1.33 is the actual EMF, right? So E equivalent is less than E2. So this statement is wrong. Okay, so this is definitely less than 2. So equivalent cannot be greater than E2, so this statement is wrong, and this is obviously greater than 1 as well. So E equivalent less than E1 is also wrong, right? So once you have used some real values, and values you can choose based on your convenience, so that you get some easy calculatable values. Okay, so here we have taken 1 and 2 based on the fact that we can easily calculate it. Okay, so only thing you have to be careful that this condition is satisfied. Okay, once this condition is satisfied, you can choose any values, does not matter. You can try with 3 and 4 as well. Try and solve it and let me know in the comment below. So E1 is less than EQ is less than E2. So this is also looks correct, but here it is mentioned that and E equivalent is nearer to E1. Now if you see that 1.33, is it nearer to 1 or is it nearer to 2? So both options are same. Okay, one case it is said E equivalent is nearer to E1 and E equivalent is nearer to E2. So this portion is same, this portion is correct obviously. Now we have to determine what is nearer, who is nearer to this equivalent voltage. So difference between 1 and 1.33 is 0.33, and the difference between 1 and 2 is 0.67. Now who is higher? Obviously 0.67 is higher. That means who is nearer? 1 is nearer. That means it is nearer to E1. Okay, so E1 is less than E equivalent, E equivalent is less than E2, and E equivalent is nearer to E1 than E2. So option C is correct. Right, interesting question, interesting approach to solve this question, and this question came in 2025. Okay, but very underrated question, very good question in my opinion. So only thing you have to do, you have to take some real values and understand the meaning of the question to solve it. It will take some time. It is not solvable in 60 seconds, but you can solve it less than 2 minutes. Now next question, the variation of intensity resistivity rho with absolute temperature T for 3 different materials X, Y and Z are shown in the graph. Identify the material X, Y and Z. So here if you see the graph properly, here we have X, Y and Z. So for X, the resistivity increases with increase in temperature. Okay, for Y, resistivity is almost flat, it is changing linearly with temperature, but it is almost constant. And for Z, resistivity is decreasing with the temperature. Which element decreases resistivity with temperature? That is called semiconductors. So this is semiconductor. And which element increases the resistance? They are called conductors. And which element remains almost same? They are alloys. Okay, so now let's see the options. X is semiconductor, Y is nichrome, Z is copper. So here nichrome is an alloy and copper is a conductor. So who is conductor? Conductor is X. So X is copper, Y is nichrome and Z is semiconductor. Okay, so option C is correct. Okay, option C is correct, right? Y is nichrome, Y is alloy, alloy is nichrome, Z is semiconductor, which is decreasing resistivity. So option C is correct. Next question. Before going to next question, I just wanted to tell you that our ABHYAS KCET test series is now launched, and if you want to purchase it, you can go to the link given in the description section and you can purchase it. The entire price of the ABHYAS KCET test series is 1499 only. What you will get? You will get 35 KCET tests. Okay. You will also get chapter wise KCET PYQs last 10 years PU2. Okay, chapter wise KCET PYQs you will get in the form of quiz, real KCET exam pattern and timing. So when you are attempting any tests, you have to finish them within the given time limit, and that will give you a practice of how many questions you are able to answer in 60 minutes for all subjects, and that's how you can prepare. Okay, PCM, B all are covered in this series. Okay, you will get P, C, M and B, everything is covered. Total 35 KCET tests, KCET level test, not only KCET test, it is a KCET level test. Also you will get chapter wise KCET PYQs. And if you don't believe me, the toppers, they all had this course last year and they performed exceedingly well. Prajwal got 171 rank, Kiran got 443 rank, Deeksha got 693, and so far and so on. Okay, so many students got rank well within 1000 ranks. Some students do not prefer to feature in over here, so their names are excluded. Otherwise, there are a lot of students, they perform really well through the KCET test series, right? So you don't wait, okay, for more. We are launching it little early. We have launched it little early so that you can prepare the for KCET for future as well, right? Now let us continue with today's session. Given a current carrying wire of non-uniform cross section, which of the following is constant throughout the length of the wire? So we have a non-uniform wire. Non-uniform wire means the diameter of the wire is changing. If diameter of the wire is changing, we know that the current is constant. Current does not change with the diameter, only drift velocity can change. Okay, so current is the only thing that remains constant if the wire is non-uniform. Okay, not even current density is constant. Current is the only quantity which remains constant. Okay, current, electric field, drift speed does not change, remains constant. Drift speed is proportional with the area. Okay, area times drift speed is a constant quantity, but it is only drift speed is not constant. Next question. The graph between variation of resistance of a metal wire as a function of its diameter, keeping other parameters like temperature constant. So we know that resistance of a wire is inversely proportional to its area, right? Resistance is directly proportional to its length and inversely proportional to its area. Now what is area? Area can be written as pi r square for a cross section, okay, of radius r. Now if radius is r, what is diameter? Diameter is 2r, or r is diameter by 2. So if you put it over here, you get pi d by 2 whole square, or pi by 4 d square. Okay, so resistance is inversely proportional to area, so resistance must be inversely proportional to 1 by pi by 4 d square. Now what is this pi by 4? Pi by 4 is a constant, so if resistance is proportional to this thing, then resistance will also be proportional to 1 by d square. Resistance is also proportional to 1 by d square, right? So now we know that this is an inverse square relation. Inverse square relation means graph is like this, non-linear graph, and it is decreasing with time. Okay, so non-linear graph decreasing with time is only this one. This pattern is the most asked pattern in KCET exam. So if you don't know the answer, there is a chance that 60% chance that this will be the correct option. Okay, there are some other patterns as well, but this is the most asked pattern. So 60% of the time this pattern turns out to be correct. Okay, and other patterns have 10% or 15% possibilities. Now next question. E vector is the electric field inside a conductor whose material has conductivity sigma and resistivity rho. The current density inside the conductor is J vector. The correct form of Ohm's law is. So we know that J equals to sigma E is the another form of Ohm's law. But if you see that option is not given over here. J equals to sigma is not given. So what we will do? We will try to find E vector. E equals to J vector by sigma. Now 1 by sigma, that is reciprocal of conductivity is resistivity. Reciprocal of conductivity is resistivity. So that means it will be rho J. Okay, so E will be equals to rho J, that is another form of Ohm's law. So E equals to rho J is correct answer. Next question. In the circuit shown, the end A is at potential V0 and end B is grounded. So basically the voltage difference between these two is V0. One side is V0, another sound is grounded, means it is 0. So the voltage difference is V0. Okay. The electric current I incident in the circuit is. So what is the electric current I indicated in the circuit, not incident, sorry. So what is this current I? How to solve it? So you have to simplify this circuit and find the equivalent resistance. If you can find the equivalent resistance, V divided by R gives you the current. Now how to do that? Now you have to remember that this pattern, this special pattern that is shown over here in the diagram represents Wheatstone bridge. Okay, so if you just take these 2 points, you will get, it is like, you can draw this diagram like this. With some clever drawing, you can easily draw it like this. So what is this? This is a Wheatstone bridge. All the resistances are R, and R. So is it a balanced Wheatstone bridge? Definitely it's a balanced Wheatstone bridge, because R by R equals to R by R. So this is a balanced Wheatstone bridge. So balanced Wheatstone bridge means what? There is no current that is passing through this central resistance, so you can simply erase it. Okay, and if you can erase it, what is the equivalent resistance of this combination? So equivalent resistance of this will be given by R plus R is 2R, and in parallel we have another R plus R, that is 2R. So you need to practice Wheatstone bridge related problems. So both of them are 2Rs. So what is the equivalent resistance of this? 2R into 2R divided by 2R plus 2R, which will turn out to be R. Okay, so when you see a pattern like this, you can directly apply this formula. You don't need to solve it. You already know in your head that this is a Wheatstone bridge pattern. That means we can simply ignore this central resistance. Okay, and if all the resistors are same, in this case all the resistors are R. Okay, so the equivalent resistance will also be R. If they are not same, suppose it is R 2R, R 2R, then you have to use this formula and apply it. Okay, you have to, the only thing you have to check is this divided by this, is it equals to this divided by this or not? If yes, then it's a balanced Wheatstone bridge. Now how it is a balanced Wheatstone bridge? You have to take this, write this and rearrange the points. Okay, points can be rearranged, only resistances are like this, right? So points are rearranged and you can get this configuration. Okay, so this, if all the resistances are R, then equivalent resistance will also be R. If the resistance are different, only thing you have to check R by R equals to R by R or not. If yes, then this is a balanced two-stone bridge. You can simply delete the central part and then do this part. Okay, add these two, R plus 2R, R plus 2R, then you have to apply the formula directly and solve it, right? So this is R. Now here also, if you see, same pattern, only difference is that instead of R, everything is 2R. So again, you can simply delete this portion. This portion does not exist because no current is passing through this, so you can simply delete this. And you want, what is the equivalent resistance in this case? Equivalent resistance will definitely be 2R. Okay, the equivalent resistance will be 2R, right? So what is the total resistance? So this entire combination is R, this entire combination is 2R, so the total resistance in this case is R plus 2R, that is 3R. So the total resistance of the combination is 3R. Now what is the current in this case? Current will be the voltage difference, that is V0, divided by the resistance, that is 3R. So the current in this circuit is V0 by 3R. V0 by 3R. Correct answer, option D. Very interesting question, right? And this kind of questions are common in KCET. So do practice such questions. Next is electric current flowing through a given conductor varies with time as shown in the graph below. The number of free electrons which flow through a given cross section of the conductor in the time interval 0 less than equals to t less than equals to 20 seconds. So we have to find the charge or free electrons which is flowing through the given conductor in this given time. So first of all, what you have to do, you have to calculate the charge. Okay, charge, if we can calculate the charge which is passing, then we can use the quantization principle to calculate the number of electrons. Okay, so how to calculate the charge? Only thing that is given a graph. So you have to memorize that for I versus T graph, if you can calculate the area under the graph. Why so? So this is basically comes from the fact that I equals to dq by dt. Okay, so if you take the integration, I equals to dq by dt, or dq equals to I dt, and if you integrate both sides, you get charge equals to I dt. I is not constant, by the way, here. So now integration means area under a graph. If you plot I versus T graph, then area under the graph, in this case I versus T graph is plotted, area under the graph will give you the total charge. Okay, that is the main reason. Now how to calculate the area under the graph? Here we have a shape. You can either calculate the area like this, okay, a trapezoid, and there is a square. Not square, this is a rectangle. So what is an area of a trapezoid? This is a trapezoid, okay. So there is one more way. You can calculate the area of the triangle, this small rectangle, and then the large rectangle. That is one way. But we don't want to waste too much time, so we have to learn how to calculate the area of a trapezoid. Okay, so area of the trapezoid, if we can calculate, we shall be good to calculate the area. So this is the trapezoid, and this one is the rectangle, right? So how to find the area of a trapezoid? Area of a trapezoid is given by half into sum of the parallel sides. Sum of the parallel sides. So in trapezoid means two sides are parallel and two angles are 90 degrees, but another side is not parallel. Okay, so in that case you can calculate the area by sum of the parallel sides. That is, in this case this is 200, this is 0, so this must be 100. This point, so this is important, so this point must be 100 and this point must be 300. Okay, so this is point between 200 and 400 must be 300. This is a midpoint of 0 to 200, that must be 100. Okay, and it is given in milliampere. Okay, this is given in milliampere. Now what? So half into sum of the parallel sides. Parallel sides is, this is 100, this is 300. Sum of the parallel sides into the distance between them. Distance is 0 to 10, right? So distance is 10. This is the area of the trapezium. This is, we are calculating the charge, by the way. And not done yet, we also have to add the area of this rectangle. What is the area of a rectangle? Length into breadth. What is length? Length is 300. And what is breadth? Breadth is another 10, right? So now calculate. So half into 400 into 10 plus 3000. Right, this one is 3000. So now cancel this, this will get 200. So 200 into 10 is 2000. 2000 in 3000 is 5000. 5000. Now here, this is, what is this? This is millicoulomb. Why millicoulomb? Because the current here given in milliamperes. Current is given in milliamperes, time is given in seconds. So that means the charge will be in millicoulombs. To convert it into coulombs, what we have to do? We have to multiply with 10 to the power of minus 3. Okay, that is 5 coulomb. So the total charge, if they ask you what is the total charge, then you could have easily said, okay, total charge is 5 coulomb. But they ask you the amount of electron or number of electrons. So number of electrons is given by the charge divided by charge of an electron. Now, what is the shortcut? The shortcut is you have to multiply with 6.25 into 10 to the power of 18. Okay, if you multiply this, you will directly convert the charge to number of electron. Okay, 1 by E is 6.25 into 10 to the power of 18. If you remember that, it will save you some time. This is a shortcut. Okay, so we get 31.25 into 10 to the power of 18. So what is the value? 31.25 into 10 to the power of 18, or 3.125 into 10 to the power of 19. Okay, this is a shortcut you should remember. Otherwise, it is very difficult for you to remember E 1.6, divide by 1.6, then multiply, cancel it, and you calculate it. It will take some time. But if you remember 6.25 into 10 to the power of 18, 1 by E equals to 6.25 into 10 to the power of 18, then it might save you some time, especially for quantization related problems, right? So we have figured this out. Next question. The IV graph for a conductor at two different temperatures, 100 degrees and 400 degrees, is as shown in the figure. The temperature coefficient of resistance of the conductor is given as. Okay, so you have to find the temperature coefficient, and they have given you a graph. Okay, they have given you a graph, 30 degrees and 45 degrees, current is given, voltage is given. Oh, what sir, how to calculate this? This is tumba difficult. So don't worry, I am here. Okay, so here we are given I along one direction, V along one direction. Okay, so I is along Y direction, V is along this direction. So we know that slope of a line, slope of a straight line is given by delta y by delta x. Okay, slope is given by delta y by delta x. And what is I by V? Okay, V is equal to IR. V equals to IR. From Ohm's law we know that V equals to IR. So I by V must be equals to 1 by R. I by V must be equals to 1 by R. So slope of this graph, if you can calculate the slope of this graph, okay, you will get 1 upon resistance, or resistance will be given by 1 by slope. So resistance is given by 1 by slope. Now what is slope? Slope is nothing but tan theta. If the theta angle is known, then slope is given by tan theta. So that's it. From this graph we have to calculate the resistances and then we will calculate the coefficient. First of all, for what is the slope for first is 30 degrees. Okay, so R1 is 1 by tan 30. We do not know which one is 400, which one is 100. We will try to calculate and we will see who is greater. That will be 400. Who one is smaller will be 400, right? Now what is tan 30? Tan 30 is 1 by root 2. So sorry, 1 by root 3. So that means it will be root 3. Root 3 means 1.73. So this is the resistance R1 for the line 1. Okay, for the line 1. What about line 2? Line 2, the resistance is 1 by tan 45 degrees, which is 1 by 1, that is 1. So who is for 400? Who responds to 400? This one responds to 400. This one must be response to 100. Why? Because higher the resistance, temperature should also be higher. Lower the resistance, temperature should also be lower. Now how to calculate the temperature coefficient? Okay, how to calculate the temperature coefficient? Very simple. R100 can be written as R0 into 1 plus alpha into 100. Okay, R0 is temperature at 0 degrees. Okay, and R400 can be written as R0 into 1 plus alpha into 400. Okay, so if you divide this, you will get R400 divided by R100 equals to 1 plus 400 alpha divided by 1 plus 100 alpha. Okay, so this is a way to calculate. You cannot use 100 as base for R400. Okay, that will give you some errors. Okay, this is the actual way to calculate. Now R400 is root 3. Okay, root 3, we'll keep it as root 3 for now, divided by 1 equals to 1 plus 400 alpha divided by 1 plus 100 alpha. Okay, now cross multiply. What we will get? We will get, let me write it over here. So what is root 3 into root 3 plus 100 root 3 alpha equals to 1 plus 400 alpha. Okay, 1 plus 400 alpha. So root 3 minus 1 equals to 400 minus 173 alpha. Okay, so alpha will be equals to 0.73 divided by 227. Okay, alpha is 0.73 divided by 227. We have taken value of root 3 as 1.73. Okay, so if you put that, you can easily calculate it. Now what? So if you see the options, you have to simplify it. So it will be 730 into 10 to the power of minus 3. All the options have 10 to the power of minus 3. So we have multiplied with 1000 and make this 10 to the power of minus 3 divided by 227. Okay, so now approximately what will be the value? Is it 4? No. Is it 3? It is very close to 3. Okay, it is not even 4 because 4 to the 8. That means if it is 800 plus, then it will be close to 8, close to 4. But 720, if you multiply 2 into 3 is 600 and something. Okay, 600 into 691 approximately. So the result is approximately close to 3, slightly more than 3. Okay, so 3 into 10 to the power of minus 3. So if you see the options, only one makes sense, which is this. Okay, this will be slightly more than 3, but approximately the correct answer is 3. Okay, if you take the exact value of root 3, exact value everywhere, you might get the correct answer, but as I mentioned, this is also perfectly fine. Now next question, an electric bulb of 60 watt 120 volt is to be connected to a 220 volt source. What is the resistance should be connected in series with the bulb so that the bulb glows properly? So for that, bulb watt and voltage is given. The source voltage is 100 volt more than that of the given bulb. That means what? That means that whatever resistance you apply, that resistance will absorb this extra 220 minus 120 volt. So the voltage drop across the resistance, should be this extra 100 volt. Now, how to do that? First of all, you have to know that the bulb is glowing properly. Bulb is glowing properly means bulb is consuming this 60 watt power. Okay, bulb is consuming this 60 watt power. That means what is the current in the circuit? Current is given by power divided by voltage. Right, P equals to VI, power is Vodafone Idea. So power is given here as 60 watt. Voltage is given here as 120 volt. That means current is 0.5 ampere. So we have calculated the current. Okay, now if the resistance in the circuit is R, okay, resistance is R, then what is VR? VR is I into R, obviously, and that must be this extra 100 volt. Okay, so what is I? I is 0.5. Resistance we do not know, so this will be 100. And R equals to 100 divided by 0.5, that is 200 ohm. So we need to connect at least 200 ohm so that bulb will glow properly. Next question, for the given electric current, the drift velocity of conduction electrons in a copper wire is Vd and their mobility is mu. When the current is increased at constant temperature, Vd remains the same, mu increases, Vd decreases, mu remains the same, Vd remains the same, mu decreases, Vd increases, mu remains the same. Let us understand. So for a given electric current, the drift velocity of conduction of electron in a copper wire is Vd and their mobility is mu. When the current is increased in the constant temperature, so you know that mu is proportional to the relaxation time. Okay, Ne square tau by m. Okay, if you remember the derivation, mu equals to Ne square tau upon m. So mu is proportional to tau. You don't need to remember this equation, you just need to remember that mu is proportional to tau. Now tau is directly inversely proportional to temperature. Higher the temperature, less is the relaxation time. So if temperature is constant, tau is constant. If tau is constant, then mu must be constant. Okay, so mu remains the same is the correct option. Now what about drift velocity? So for that we know that current I is given by NEA Vd. So Vd is given by I divided by NEA. Okay, so current increased means you are increasing current I, so drift velocity also should increase. If current is increasing, drift velocity should also increasing. So Vd increases but mu remains same. Vd increases but mu remains same. 10 identical cells, each of EMF 2 volts and internal resistance 1 ohm are connected in series with 2 cells wrongly connected. So 10 out of the 10, 8 cells are properly connected. So remember that we have cells, okay, 8 of them are properly connected. Okay, only 2 are wrongly, 8 are properly connected. So say these are the properly connected ones. Okay, 8 of such cells are connected properly and 2 of them are wrongly connected. Wrongly connected means what? Their polarity is inverted. Okay, so positive, negative, positive, negative, positive, negative, but here we have negative and then positive. negative and then positive. Okay, let me use a separate color so that it does not create any confusion. So negative, then positive, then we have internal resistance, then negative and then positive, and this concludes the circuit. Okay, now what? A resistor of 10 ohm is connected in the combination. So in this combination we have a 10 ohm which is connected. Okay, so 10 ohm is connected from the outside. Now it is said that the current through the resistor. What is the current through the resistor? Okay, what is the current through the resistor? So for that, first of all, you have to find the equivalent EMF. So this is positive, this is negative, positive, negative, like that. How many of the cells are properly connected? As I mentioned, cells properly connected are 8. So what is the total voltage across those 8 cells? Total voltage is given by properly connected cells are 8. So 8E must be the proper voltage, but we have two wrongly connected. Wrongly connected means they are connected in reverse. That means these two will have a voltage which is opposing the actual voltage, right? So these two will oppose this remaining 8. So the equivalent voltage will be 6E. Now each of them have 2 volt. So the total voltage is 6 into 2, that is 12 volt. So 12 volt must be the total voltage. What about the equivalent resistance? Equivalent resistance of cells is independent of the polarity. So equivalent resistance in series will always be number of cells times resistance of each of them. Okay, so the total internal resistance is 10 into 1, that is 10 ohm. Resistance does not have any polarity, right? Resistance will always be added in series. So what is the total resistance now? Total resistance is R equivalent plus the external resistance. So 10 plus external 10, total 20 ohm. So what is the current? Current is given by the total voltage divided by total resistance. Total voltage is 12, total resistance is 20, so it will be 6 by 10, that is 0.6 ampere. So the current in the circuit is 0.6 amperes. Okay, next, the equivalent resistance between point A and B in this following circuit. Now this circuit can be solved. I have solved it during my Sankalp lectures if you have watched it, but today I am going to tell you how to solve such questions in shortcut. If you see any such infinite circuit, like similar pattern, okay, and the resistance can be anything. It can be 2, it can be 3, it can be small r, it can be capital R. If the resistances are same, then the equivalent resistance of this combination is given by the common resistance into 1 plus root 3. Common resistance into 1 plus root 3. So this is the shortcut formula to solve these type of infinite circuits. Okay, here small r is 2 ohm, so 2 into 1 plus 1.73, so this will be 2 into 2.73, that is 5.46 ohm. Okay, so if you see all the options, only one is making sense, that is 5.5 ohm. So if you remember this formula, any such questions coming in future you should be able to solve. R into 1 plus root 3. Next question, a wire of resistance capital R is connected across a cell of EMF epsilon and internal resistance R. The current through the circuit is I. In time t, the work done by the battery to establish the current I is. So what is the work done by the battery to establish the current? It is simple. The EMF of the battery, the current into time. Okay, this is the power. Okay, and this is also the work done. Power is epsilon into I, the battery's power is epsilon into I, and the work done is basically given by epsilon I into T. Okay, next, 10 identical cells each of potential capital E and internal resistance small r are connected in series to form a closed circuit. An ideal voltmeter is connected across 3 cells. So here we have all of them are connected properly. We have 10 cells. Okay, and you take a voltmeter, you connected them across 3 cells. Now this is E, this is E, this is E. So the voltmeter which should read 3 E's. Okay, so though no matter how many resistances are connected in series, if they are connected in series, then the voltmeter will read the combined voltage. If they are connected in parallel, then voltmeter will read exact E. Okay. Now here it will be exactly 3, not less than 3, not less than 3. Less than 3 is not the answer, because if you connect the voltage, the current is not flowing in the circuit. It's an open circuit, so current is not flowing, so it will measure 3. If current is flowing, then you have to subtract the small r's. So if the same circuit is connected across some resistance, okay, then the voltage will be less than 3. Then the voltage measured will be less than 3. Okay, otherwise if no external resistance, it will be equals to 3. Clear your concept? Now next question, before going to next question, next chapter actually. So this chapter is over, current electricity. So as you can see, a lot of interesting questions we have solved for last few years. Now we will be moving into alternating current, another important chapter. Let's move on. In domestic electric main circuit, the voltage and current are. So easy question came in 2025, and you will not believe the question is so easy. Obviously AC voltage and AC current. We use AC voltage and AC current because of its convenience, right? Next question. A sinusoidal voltage produced by an AC generator at any instant t is given by an equation V is equal to 311 sin 314 t, the RMS value of the voltage and the frequency respectively. So V is given by V0 sin omega t. Okay, so V0 sin omega t, or what is omega, by the way? Omega is nothing but 2 pi into frequency into t. Omega is given by 2 pi f. F is frequency. Okay, so any voltage or current can be written like this form. Here V0 is the peak value of the voltage. So what is RMS value? RMS value is given by V0 by root 2. So here peak value is 311 divided by root 2, and that will give you 220 volt. Okay, now obviously calculators are not allowed, but you should remember this specific term 311. 311 is actually when you multiply 220 with root 2. Okay, this value is very familiar and it appeared in your textbook multiple times. So 311 is the value when you multiply 220 with root 2. So if you divide 311 by root 2, you should get back to 20 volts, slightly less than 220 volt, because 311.1. okay, if you multiply, so it will be okay. Now what about 314t? So 2 pi f must be equals to 314, right? So this 2 pi f must be equals to this term, right? What is pi here? Pi is 3.14, so it will be 314. Okay, so f equals to 314 divided by 2 into 3.14. So this cancels, gives me 100, and 100 by 2 gives me 50. So the frequency is 50 hertz. Okay, so VRMS is 220 volt and frequency is 50 hertz. So correct answer is 220 volt 50 hertz. Next, a series LCR circuit containing an AC source of 100 volt has an inductor and a capacitor of reactances 24 ohm and 16 ohm respectively. If the resistance of 6 ohm is connected in the series, then the potential difference across the series combination of the inductor and capacitor only is. Okay, so the voltage given here is 100 volt. The capacitor and capacitor reactance and inductor reactances are given. Now what you have to do, first of all, you have to calculate the impedance of the circuit. How to calculate impedance? Obviously we will use the formula R square plus XL minus XC whole square to the power half, that is root 2 of this thing. Okay, basically just a fancy way of writing. So 6 ohm is 6 square plus 24 minus 16 whole square to the power half, or it will be 36 plus 64. Okay, 24 minus 16 is 8. 8 square is 64. 64 and square root. So we get 100 square root, that is 10. So the impedance of the circuit we have calculated is 10. Now what about the current in the circuit? Current in the circuit is given by the voltage that you have applied divided by impedance. Voltage here is 100 volt. So 100 divided by 10, that is 10 ampere. So 10 ampere is the current in the circuit. So current is calculated. Now what? You have to find the voltage drop across the capacitor and inductor only. So voltage drop across capacitor and inductor is given by XL minus XC into I. Okay, they are in opposite phases, that's why XL minus XC. XL is obviously 24, XC is 16 into 10, so it will be 80 volt. So XL minus XC, voltage drop across the capacitor and inductor, is 80 volt. So correct answer is 80 volt. Which of the following combinations should be selected for better tuning of an LCR circuit used for communication? Now this question is out of syllabus because this is related to Q factor. Okay, so this question is now no longer part of the syllabus. This question is deleted. Next, and we are not doing any deleted questions. In an LCR series circuit, the value of only capacitance C is varied. The resulting variation of the resonance frequency F0 as a function of C can be represented as. So what is resonance frequency? Resonance frequency is given by 1 by 2 pi square root of L into C. Now if you vary only capacitor, then we can say that frequency is inversely proportional to square root of C. Again another inverse proportional equation. So inverse proportional equation means again this graph is correct. So as I mentioned, this pattern is repeated consecutively many times. So this pattern is again turns out to be correct. So if you don't know how to answer it, and if you see this kind of graph, there is a chance that 60% chance this will be correct, and remaining ones will have 15% chances. Right, now next, in the figure shows variation of R, XL and XC with frequency F in a series LCR circuit. For what frequency point is in the circuit is capacitive. For what point in the circuit the circuit is capacitive. Capacitive means what? First of all, circuit is said to be capacitive if XC is greater than XL. If this condition is satisfied, then we say that circuit is capacitive. Most part of the journey, it is basically a inductive circuit because XL generally is more than XC. So circuit is mostly inductive, but there are few cases where XC can be greater than XL. That is called capacitive circuit, and that depends on the frequency. Sorry, my screen froze. Give me a moment, my screen frozen, I will be back. So now if you see this graph, what happened over here is XC is decreasing like this, XL is increasing like this, and resistance is constant. Resistance will not play any role. You can simply ignore resistance over there, okay? And where XC is equals to XL, that is this point is the point where circuit is in resonance. So this is the point of resonance, right? So this is the point of resonance. That means what happens here is any point which is beyond this point at this side of the circuit, if you observe this point here, the value of XC, this is XC, and this is the value of XL. Who is more, XC or XL? So this is XC, this is XL. So as you can see, any point before resonance, XC is greater than XL and the circuit is capacitive. So this region is where the circuit is capacitive. Any point beyond this region, circuit is capacitive, and all the region next to it is circuit is inductive. Okay, all the part on the right hand side, circuit is inductive. Okay, and on any point where circuit is on the left hand side of the resonance point, circuit is capacitive. Okay, so only for point A the circuit is capacitive. So correct answer is A, but be careful, A is given in option C, so option C will be correct. Okay, in KCET generally 1, 2, 3, 4 is given, not ABCD. Okay, so that's why it is coming at C with matching with A, but don't worry. So if you see such kind of question, make sure you tick on the correct option, not on this option. Okay, next question. In series LCR circuit at resonance, the phase difference between voltage and current. So as at resonance, so resonance is a very important concept. Okay, resonance is a very important concept for KCET related questions. You will find at least 1 or 2 questions which is basically based on resonance. Okay. Now in series LCR circuit, the resonance phase the phase difference between voltage and current is 0. Okay, at resonance XL is equals to XC. That means current due to inductor and current due to capacitor, they cancel each other. That's why current and voltages are always in phase, and the power consumption is also the maximum. An ideal transformer has turns ratio 10. When the primary is connected to 220 volt 50 Hz AC source, the power output is equal to power input. Ideal transformer does not require the turn ratio. We do not need the voltage. We should only be careful that if it is an ideal transformer, then power input should be equals to power output. It does not have anything to do with turn ratio or voltages. Just to give, they are only given you to confuse you. Okay, don't get confused. Be confident that okay, ideal transformer means power is constant. Which of the following represents the variation of inductive reactance with the frequency of the voltage source? So this is one of the cases where this pattern is not correct. Okay, so even last 2 cases we found this pattern is correct, but in this case it is not. Inductive reactance XL is given by 2 pi F into L. Okay. So we can say that inductive reactance XL is directly proportional to frequency F. So that means it's a straight line passing through the origin. It's a straight line passing through the origin. That is option A is correct. So this is one case where this pattern is not correct. An alternating current is given by I equals to I1 sin omega t plus I2 cos omega t. Okay. So the RMS current is given by the RMS current. When you are adding 2 separate currents, the RMS current will be square of the individual currents divided by 2. Okay, so if it is say current is I1 sin omega t plus I2 cos omega t, okay, then it will be I1 square plus I2 square by 2 whole root. If both of them are sin omega t, then what will be the answer? Try to mention that in the comment section below. If I1 sin omega t plus I2 sin omega t, then what will be the equivalent current? If you are watching till this point, then you should answer that question in the comment section below. Next, a series resonant AC circuit contains a capacitor of 10 to the power of minus 6 farad and an inductor of 10 to the power of minus 4 Henry. The frequency of electrical oscillations will be so this is a series resonant circuit. So what is the formula for resonance? Resonance formula is F naught equals to 1 by 2 pi square root of L into C. Okay, so first we will calculate L into C. L is given here 10 to the power of minus 4 Henry and capacitance is given by 10 to the power of minus 6 farad. So we get LC equals to 10 to the power of minus 10. Okay, so what about square root of LC? Square root of LC will be square root of everything. So this will be 10 to the power of minus 5. So now we will put that value over here. So 1 by 2 pi into 10 to the power of minus 5 or 10 to the power of 5 divided by 2 pi. Right? So if you see all the options, 10 to the power of 5 divided by 2 pi. So this will be the correct answer. Okay, easy peasy lemon squeezy. Next question, in a series LCR circuit, R equals to 300 ohm, L equals to 0.9 Henry, C equals to 2 microfarad and omega equals to 1000 radian per second. Then the impedance of the circuit is, to calculate impedance, first stage is to calculate XL. XL equals to omega L. Because frequency is not given, omega is given. This is not your PU2 exam. PU2 board exam, they try to give the values such that you require a calculator and the values are slightly complicated. But in KCET, if any question comes, the values will be given to you such a way that you should be able to solve them without using calculator. Omega is 1000 and L is 0.9 Henry. So this will be 900. Okay, so the XL is 900. What about XC? XC is 1 by omega C. That is 1 by omega is 1000. C is 2 microfarad. Micro means what? Micro means 10 to the power of minus 6. Okay, so this will be 1 by 2 into 10 to the power of minus 3. Why minus 3? So this was 10 to the power of 3, this was 10 to the power of minus 6. That means this will be 10 to the power of minus 3. So we can write this as 10 to the power of 3 divided by 2, that is 1000 by 2, that is 500 ohm. So XC and XL are calculated. Now what is impedance? Impedance is simply R square plus XL minus XC whole square to the power half. Right? So R is given here as 300 whole square. Next is 900 minus 500 whole square and to the power half. So it will be so you can take 100 common. So 100 into 3 square plus 4 square to the power half. Okay, so this is 3 square. This will be 900 minus 500, that will be 400. We have already taken 100 outside, so that means only 4 is left. So we got 100 into 5. Okay, this is 3 square plus 4 square is 5. So you got 500 ohm. So the impedance of the circuit is 500 ohm. Option A is correct. Next question. What will be the reading of the voltmeter and ammeter of the circuit shown? So here it is given that XC is 4 ohm, XL is also 4 ohm. XC and XL both are 4 ohm. R is 45 ohm. Okay, R, even though R is not properly shown in the diagram, so there is an R over here. Okay, and R is 45 ohm. So what is the reading of voltmeter and ammeter? First of all, because XC and XL are same values, that means the circuit is in resonance. This is only possible when the circuit is in resonance. If XC equals to XL, then the circuit is said to be in resonance, and if the circuit is in resonance, then what happens is that there is no voltage drop across this, so voltage drop should be 0. The voltage reading of this branch, because this branch no resistance is there, means voltage drop should be 0. Current is passing, obviously current will not be 0. Okay, what about the current value? Current value is simple. Current value at resonance, it is voltage divided by the simple resistance. So 90 divided by 45, that is 2 ampere. So 0,2 ampere is the correct answer. 0,2 ampere we will also mark. Next question. A series LCR circuit contains inductance 5 millihenry, capacitance 2 microfarad and resistance 10 ohm. If a frequency AC source is varied, what is the frequency at which maximum power is dissipated? Again, interesting question. So the maximum power is dissipated at resonance. Okay, so directly or indirectly they will ask question based on resonance. Okay, so here the only we need the impedance and inductance and the capacitance. What is resonance frequency? Resonance frequency is again 1 by 2 pi square root LC. Okay, so L here 5 millihenry. So we will start with again the same calculation. LC 5 millihenry and 2 microfarad. Okay, so it will be 10 to the power of minus 8 square root 10 to the power of minus 4. So what is F naught? F naught equals to 10 to the power of 4 divided by 2 pi. We have directly written it. We already solved one question, similar question. This will be in the division, then it will go up and become 10 to the power of 4 divided by 2 pi. So now if you see the option, none of the option is matching. So what we can do, we can take 110 and write it as 10 into 10 to the power of 3 divided by 2 pi, and we can cancel it. So this is a fancy way, nothing new. Only thing they have done, they have made a little tricky for you to identify the correct answer. So correct answer is this one. Okay, but if you solve so many problems, if you solve a real good number of problems, then this kind of problem should be easy for you. This is not at all a problem. You should thank the teacher who gave the question, right? Next question. A step down transformer has 50 turns on a secondary and 1000 turns on the primary winding. If a transformer is connected to 220 volt 1 ampere AC source, what is the output current of the transformer? Okay, so now it is given that step down transformer, that means voltage is decreasing. Okay, and 50 turns on the secondary and 1000 turns on the primary. So what is the secondary voltage? Secondary voltage is number of turns in the secondary divided by number of turns in the primary into primary voltage. Okay, number of turns in the secondary is 50, number of turns in the primary is 1000, and the voltage given over here is 220 volt. Okay, so let me cancel as much as possible. So we get 11. So we get 11 volt. So the 11 volt is the secondary voltage. Now they have not asked you the secondary voltage, they asked you the secondary current. So for that we will be using power input should be equals to power output. What is power input, by the way? What is power? Power is Vodafone Idea, that is V into I. So input voltage, that is primary voltage into primary current, equals to secondary voltage into secondary current. Okay, primary voltage is 220, primary current is 1 ampere. Secondary voltage we have calculated 11 volt, so we will put that 11 into IS. So IS will be equals to 20 ampere. Okay, so it will be 20 ampere. Not ampere that gives out, it is ampere. Okay, So this is the end of this lecture, and we will be back with more KCET level preparation for all of you. And if you want to prepare KCET with us, then don't forget to like, share and subscribe this video. Also don't forget to join our WhatsApp channel. The link of the WhatsApp channel is given in the description. Also consider ABHYAS KCET test preparation for your smoother experience on your KCET journey. I'll be back. Till then, bye.